Hello everyone. It's been a while. But I posted this little clip on LinkedIn on Friday showing a plugin that I made integrating ChatGPT into Revit. I got a lot of requests to show how I done that, so I figured it's a good time to make another episode of yeah, so it's a long time that I made the last tutorial of this kind, but I know that some people still watch my old videos on how to make a Revit plugin, and I figured this is a good opportunity to maybe make an updated version of that. So I'll use this opportunity to show, on the one hand, how I made this specific plugin for ChatGPT, integrating that into Revit. I want to talk about what the limitations are right now, what is possible, what isn't with these large language models. But also then on the other hand, you can use this as a good basis of how in general to make a C# plugin into Revit using the Revit API, so that anything that you were maybe planning to do, any custom tool that you wanted to create, you can use this as a basis. I'm also going to share a large chunk of the code on GitHub so that you can use that and build upon it. Let's get into it. So for this video you will need a couple of things, and you will learn also some new things hopefully. So what we're gonna do is we'll create a C# plugin for Revit, accessing the Revit API. And so for that we need Visual Studio, or at least that's the coding environment that I used. So you will need to install that. It's available for free. And there's plenty of videos where you can find on how to install it, or guides, so I'm not gonna go over that. Then what we'll also do is we'll use a WPF as that's a framework for creating user interfaces. So we'll create a little pop-up window with that, using XAML as a markup language. So we'll also go over how to use that and how to create buttons to push and things like that. Then last but not least, you will need a ChatGPT API key, so that you get from OpenAI, and you will actually need to spend some money on that to run your application, to be able to access the ChatGPT API and to receive your answers. But it's not very expensive unless you get into like where you have thousands and thousands of requests and pull like messages basically being sent back and forth between you and the ChatGPT API. So if you want to get started, for example, what I did is I just put $5 on my account there, and then so far that's lasted me a very long time. So let's get started. I put the code that you'll need on GitHub, so you can clone it from there and open it in your Visual Studio, and we'll go over it step by step. Since we're working with C#, what we're doing is called like object-oriented programming. So we're packaging the code into classes that interact with each other. So first I will go over the different classes that I made, and then we'll go through the code step by step. Okay, so what I did for this video is I created a simplified version of the tool that I shared before, which is called Little Helper, and that's also the code that you will find on GitHub. What this is basically a chatbot that you could ask any question that you have about Revit or any problem, and it will help you solve it. What it will not do is create elements for you. That is what I use this ChatGPT assistant for. It's a bit more complex and doesn't run as stable. So I figured for this tutorial, we'll start with this little helper just to explain how to make a plugin for Revit in the first place, how to create this window that you could type question into, like for example, how to create a double pitched roof in Revit, and then receive answers from ChatGPT. So I'll show you exactly how to do that, how to create that connection to ChatGPT. And you can use this, for example, as a tool to hand out to people who are new to Revit and want to learn Revit. And then after we looked at that, I will also show you how then I created this ChatGPT assistant that also can create elements for you. And yeah, we'll talk about how it works, how it maybe doesn't work so well. And you can then use this basis that we created with the little helper tool to explore LLMs for yourself and see how you can make them useful for yourself. Okay, so the little helper plugin consists of 4 classes basically. If maybe you're not so familiar with object-oriented programming, maybe you've only used Python before, then I would recommend you to look into what classes is, what object-oriented programming is. But just to keep it simple, basically it's a way to structure your code into bundles with certain functionality so that you have some structure in your code and you can reuse certain parts of your code and so on. Okay, so what we have here is, so they kind of belong together, like I call it app CS and command CS. Basically, there are 2 classes that establish your plugin in Revit. So the app CS is what creates this little panel here with my logo and then the name here, and then it has a button and so on. And then the command CS is the functionality of what happens when I click on it, that it opens our application. And then our application consists of the user interface, which is called chat window. So this is what you saw before, is where you can type in your questions and receive responses. So that consists of 1, the XAML file. So that's the markup file where we say what exactly we want this window to look like, that it has here this type field and then a button to send, and here like all of the chat history. And then the C# part of it is the functionality of that it sends the user messages to ChatGPT, and it also displays the responses and the whole chat history. And then the 4th class here is the ChatGPT service class. That one establishes your connection to the actual OpenAI server. So it contains your ChatGPT API key. So that's what I mentioned before. That's like your personal credential for the OpenAI API. And then it also contains the system prompt, which is kind of an important part. So the system prompt is basically your universal instruction that you give to ChatGPT for how you want it to act. So in this case, I told it to be like helpful, Revit assistant, helping the user with whatever problems they have. You can also define like the tone of voice that you would like them to use. Exactly. So that's what you define there. And also if there was any problems with your contact to the ChatGPT server, then you would also receive your error messages there and then send them back to be displayed in the chat window. So for example, if your API key isn't working or you don't have an internet connection or something like that, that's
where you would receive that error message. Good. So basically how I structured this is you have 3 parts. The one that interacts with Revit here, so these 2 classes. Then the part that interacts with the user, so creating the user interface and extracting like the information for the user and displaying the answers that they're trying to get. And then the third part that works in the background basically and connects to ChatGPT and handles that connection. Okay, let's look at what this looks like in real code now. So you can either download or clone the repository that I put on GitHub. You find it in the link below. And then what you want to do is open the solution file or SLN. And then once you've done that, it should look something like this. So you should find the 4 classes that we talked about, the app and the command, and then the chat window that consists of the XAML and the C# file, and then the ChatGPT service file. So, and if we start looking at the app file, so I'm not going to go through each line of code one by one. I want to rather talk about like the functionality so you can understand what's happening, and then you can on your own look at the code like one by one to understand it better. But basically most of this code that we have here you would use for any plugin that you want to make for Revit. So this is a good template to use basically. So if we look here at the functions that we have, we can see there's only 2, so it's pretty simple, just on startup and on shutdown. So this is basically when we start Revit, what do we want it to do, and when we close it down, how do we like clean up after ourselves. So in the startup one, so this gets triggered when we launch Revit. We want it to make sure to include our application, right? Our little app that's included under the add-in panel. So what we need to do for that is create a ribbon panel. So the ribbon panel class is like a predefined part of the Revit API, which we include by including the Revit API references in our code. And then we get to use these predefined functionality to make our life easier. So here, this ribbon panel, we say that we want to create a new one that's called Little Helper. And in this panel, we want a button. And for that, we can use this push button data class. And when we look at it, here we can see it requires 4 things. A name, a text, so that's the text that just gets displayed in the user interface. And then here an assembly path and a class name. And this is basically our pointer towards the class that holds the functionality, which is in our case this command class. So we give it a name and we write the text that we want to display, which in this case is just Little Helper. And then the assembly path is the same as the one that we're already in. And we wanted to look for the class that's called command, which is this one. And then basically we just need to add our push button to our ribbon panel. And then you can add an image as the little logo that gets displayed. So I should have probably made this dynamic. So you will actually need to change this part to point towards the location where you have this saved on your computer. But basically that you have this image included as a little logo. And then this part of the code just adds the image onto the button. This can be probably done similar. I just had some issues in the beginning, so I made a little test to make sure it can actually load the image, or else it displays an error message. Okay, and then back to the important part. So the command class that we want to run. And then in our command class, we only really have one function, which is the execute function. We overload this. This is basically also boilerplate, and we overload this with the functionality that we want to have in our specific application, right? Which in this case is pretty simple. We just want it to open a new instance of our chat window. So basically all that we've done so far is create our panel in Revit, in the Revit user interface, and when we push it, it executes the command class, which then creates the chat window pop-up, and you can start the interaction with ChatGPT. Okay, nice. So far so good. Now the nice visual part, which is here this chat window part. So as I said before, this is an XML file using WPF, so which is a framework that lets you design user interfaces in Windows. And what's nice about it is it has some predefined building blocks, so to say, that you can use. So as you see, I created this pop-up window here piece by piece. So all of these elements, like this button or this little panel here that you can type into, or here, all of that we have to define piece by piece. Like Lego blocks, basically, there are things available that you can use. So first of all, this window block is like one of these predefined functions. So it comes basically that you have like this pop-up window that has the closing and opening and minimalizing functionality. That one we use, and I gave it a predetermined height and width and a background color, and basically then this title here, ChatGPT Assistant, is what gets displayed in the top left corner of it. And then if we only have this bit of code, basically at this point we would have a dark like rectangle of 400 by 600 pixels, and that would be popping up when we click our button in the Revit interface. And so now we can add on top of that here these 3 elements. It's pretty simple. So what I did is I defined a grid. So think of it like a matrix with, in this case, 2 rows. So I defined 2 rows with like a specific height, and then I can place things. So you can kind of see it, these blue lines define where these 2 rows are. So there's this one big one here, and then the other smaller one here at the bottom. And then I create these other elements here. So a text box and a dock panel. And I place them by defining the grid row that I want them in. So on our grid, on our matrix, we are accessing the rows that we defined. And so the first one is row 0. And that's where we want to place this text box. And then row 1 is the second row. And that's where we want to place this dock panel that then consists of 2 parts. A text box, which we call user input. So this is where the user can type in. And then a button. So that's this send button. Yeah, basically, I mean, you define the content. So this is what the text that gets displayed, the size of it. And then what's more important is what you want to happen when you click on it. So here, as you can see, I defined this send button click. And when we go later to the C# file, then you can see how we're implementing this send button click function. And then above here, this text box, this rich text box is like the chat history. So this is where you will have displayed all of our requests and then the ChatGPT responses. And it looks like just a white box now, but what's nice is that, for example, it breaks your text. So if your text would be, like your row of text would be longer than this is wide, then it automatically breaks it into multiple lines of text, and you get the scroll bar also once you exceed the space of your panel here, then that you can scroll up and down through the text. So it's quite nice to have this text box. Yeah, and then I added just some visual features. Like for example, I added like rounded corners just to make it a little bit just look more appealing. Oh, maybe not on this one, but then here I rounded the corners. I rounded the corners of the button. I did that by defining, that's up here, a style of buttons. So there's a bit of code that goes into like just the design of this button. Yeah, it's just I like so yeah, here for example is the radius, that it has these rounded corners. I just like UI, so I sometimes get a bit into these things. You don't, for the functionality of it, you don't need any of that. I just wanted it to look pretty and like this flat look. And then connected to it, you have the chat window C# part, so that defines the actual functionality of the things that you want to do. So for example, you have now here this text box where the user can type in their input, but now we need to write the code that actually, when we press the send button, it gets pushed up here into our text box, and then also that it sends it in the background to the ChatGPT service, and then also displays the answers here. So all of that functionality, that like basically like the back end to our front end here, that goes here into this C# part of the chat window. And then in our chat window class, you can see this one is pretty simple too. We only have this one method here called send button click. So, and this one should sound familiar to you because that's what we just initialized in our user interface. So this is what we wanted to be called when we click on our send button. So you can see it here in our reference. This is the send button that we just created in our user interface. So every time that gets pushed, this method gets called upon. And then in this method, so basically let's think about all the things that we want to happen when we press the send button. So basically, let's say the user types in, why can't I change the hatching of my wall? Once they press send, we want this message to go up in here to be displayed in the box, like bloop, and then it pops up here and gets deleted from here, right? So this we have to define. And then on the other hand, we of course want this not just to be displayed, but also be sent to ChatGPT. So for this, there is like two variables that we want to add to. So one is the chat history, that's what I called it. And then on that's basically, yeah, we have this append function to just add that to the chat history, and chat history is what gets displayed here. And then on the other hand, we have this conversation history. So, and why we need this is each time you send a message to the ChatGPT API, it's like you're sending a message for the first time. So it cannot remember the conversation you had with it, unfortunately. So what we need to do is we send the conversation, all that we had, back and forth each time. So all previous answers that ChatGPT gave and all previous inputs that we gave in this session, right? All of that we bundle and send it back each time so that ChatGPT doesn't lose the context of what we just talked about. And so basically, so each time we type in something new, it gets added to this conversation history. And this is basically an array that keeps track of who said what. So this is our symptom prompt. That is basically where we define for all the messages how we want ChatGPT to act. So that but that we come to later in more detail. But then here, basically the user started typing hi, and then the system replied, how can I help? And now we want to add our next message, which is the question from the user. So we want to send this message here to the conversation history. We want to add to it. We say the role is the user, and then the message is why can't I change the hatching of my wall? So in code, this looks like this. So we have here our send button click method. And first of all, what it does is it just checks. So we have the user input as a string. And what we just check is if it is it empty or not? So, right. So if it was, then nothing would happen. But if it's not empty, then we want the following to happen, which is once that we add the text user says this. So that would be this part here, user check. And then to the conversation history, we want to add a new chat message with the role user and the content, this user input. Oh, and then also this little step, just for making it intuitive, that it also deletes here the text that was displayed here, right? So that's the first thing that happens. We click the send button, it deletes it here, it pops it up here. So that's just this line of code and this line of code. And then this here is that it gets added to the message that gets sent to ChatGPT. Okay, and once that's added to conversation history, then we're going to try and send this to ChatGPT. So here, this is our conversation history with the messages that were sent before and this new message. And then we're going to wait for our response. So if this try function works, then we'll get the new message back from ChatGPT as the answer. So the response, and and that role is assistant. We want to add that to our conversation history, but then also display it to the user. So that's our chat history. So basically just backwards of what we did before. So here something's coming in, like reverse that arrow, basically going back, and we want to add that to our history and display it to the user so they can see the answer. And if that doesn't work, like if you had a problem with your ChatGPT connection, then you would get the error message from ChatGPT. And so then we want to display that also as the assistant saying, sorry, the following error occurred. And yeah, that's that. And then the next part is just this ChatGPT service get response function. So this is our last class here that connects to ChatGPT. And then here there's a couple of important parts to make it work. So when you download this code from GitHub, you will see this line here. Your ChatGPT API key goes here. So that's what I talked about in the beginning of the video. This is where you'll need to spend a little money and open an account with OpenAI to generate a ChatGPT API key. So this is basically your credential to access the ChatGPT servers. So to say, this is your key to open the door. And then the interesting part here is we also define our system prompt. So this is what I described before, where we tell our assistant what kind of personality we want it to have. So in this case, I described that it's an assistant integrated into a Revit add-in, so it kind of knows in what environment it is. And then that it should help the user with useful Revit tips and tricks. And also you can define the tone. So I said like friendly and a little quirky, because I thought that makes it more fun to interact with. Exactly. So, and then it adds this system prompt to our list of messages with the role of system. So if we go back to this graph here, so this system will always be the first message, and then we'll start with our back and forth, like adding onto it with all of the history of messages. And just this checks if there's already a system message included, and if not, it inserts that at the first place in the array, so number 0. And then the only other interesting part is, so because basically you send the whole conversation back and forth each time, so the messages you send to ChatGPT can get really long, and you just want to cut it off at a certain point because their API can't handle it anymore then. So at a max token value of 3,500, this is where we start removing like the oldest messages from the chat. But of course, we don't want to remove the system prompt, so we start telling it to remove messages at like the place number 1, so not at 0. Exactly. And then there's a bit of like boilerplate code. Here we define which model to use. So right now, this is the best freely available model, is the 3.5 Turbo. And then also, here, if we're having trouble connecting to the server, that we get like response messages. And then that is basically it. So as you can see, it's the actual code itself. It's not that many lines of code that you need to create this connection to ChatGPT. So basically now we completed all of these classes that I talked about before. So these 4 classes that create here the connection to Revit, here this user interface, and then here the connection to ChatGPT. Okay, so we went in detail now over the code that goes into making this little helper add-in, which I use as a base to make this ChatGPT assistant. The difference is this one can actually manipulate the model. So this one we can use to create elements, for example, like a wall. So I can type in my request here. I would, and ChatGPT will ask me for some more information until it feels like it has enough information. And just and then get final confirmation, yes, please, before actually then placing the element. And to make this work, I had to get a little bit creative. So basically the only thing you can get from ChatGPT is always one response. So you send a message in, you get one message back. But I wanted to split that message to have like the front end where you communicate with ChatGPT in natural language, like the back and forth between the user and the assistant, and then the back end where it sends actual API calls to the Revit API, and for that we use JSON. And so how I split that is by adjusting the system prompt. So the message that we talked about earlier in the little helper example, that defines like the role that the assistant takes. I adjusted that and told it it's a bit more complex now, that its job is to make to understand natural language user requests and turn them into Revit API calls. And it hides the Revit API calls in these JSON tags. So that basically the whole conversation is natural language, but when it feels ready to make an API call, it includes that in these two tags. Like it writes JSON in and JSON out, like at the beginning and at the end of the call. And then I wrote this function that parses each response that comes from ChatGPT. So basically, like if this message came in, like that has both the natural language and then the JSON call, it parses the response, like it detects these JSON tags, and then it sends the first part of the message, that is the natural language, sends that to that chat window that gets then displayed in the conversation in the chat history that we have with the user back and forth. And then the code part, so that the JSON call for the API, that gets sent to this other window that I made. So similar to this chat window, we have here this Revit API call log, so that you're also able to see them if you wanted to. But basically in the backend, this gets sent then to the actual Revit API. And so you can see that here, basically it took all of the information that we gave it. So 5 meters long, 2 meters high, placed it at a default location, which would be the origin at this point. So 0, 0, 0. So that's our start point. It took that information and then calculated the endpoint. So that should be after 5 meters. It just chose a basic wall type. And then as the height here, that's what we defined as 2 meters, transmit that as the height. And so this then gets translated again from like this JSON language into C#. And this is where it gets a little bit complicated. So what you can see here is I added upon the basic plugin that we just created. And I added this Revit command factory. So basically, each API call that comes in always consists of a method and then parameters. So the method describes what we want to do. And this corresponds to a method that exists in the Revit API. And then a list of parameters, like a list of information that's needed to execute that command. And then what happens in this command factory is that the JSON call gets paired with a command that we defined here in this command library. So it will basically go into this command library here and find the command with the same name as the method that we want to call. So in this case, wall create. And then it will take all of the information that we transmitted in the parameters and translate them into the right format that we need to make the API call in the end. So here, this wall create, now this is the function that is defined in Revit. This is the Revit method. And we're now transmitting all of these different pieces of information to make that command and to execute basically this, that it creates the wall in Revit. And now you see where it gets complicated, because this is just the code to create one type of element, which is a wall, right? But to make this really capable of doing a lot of different things, we would need to write a command, like a translation sheet basically for each of these methods that is defined in the Revit API. And I mean, you would probably not need each one of them, right? But a lot of them. And this is where it would get really tedious. So I started defining like some, like adding a door or deleting an element. But this is why I would be really interested if there would be someone smarter than me out there, basically, right? Because this is a very explicit way of doing this. So you have to write like a translation sheet for each one individually. And I was trying to think if there's a way to do this implicitly, that there's more of a general recipe that you would define more broadly, that it gets a set of parameters, it gets the name of a Revit API function, and it just takes whatever parameters there are and makes the call to the Revit API of that function. I think there's many ways on how this could break. So, but maybe there's a good way of how to do it. But this is where I am at the moment with this. So take this more as like a proof of concept, like it is possible to do it. The reason why I didn't continue implementing it more, I want to get into as a next part, because there is still some downfalls of this, of like the ChatGPT model. So the biggest problem I encounter with ChatGPT is that it's pretty inconsistent. So for it to make the API call with Revit, for Revit to understand what it wants it to do, it needs to write things a certain way, right? Like for example, this wall create command, it will only get triggered when you write it like wall.create as the Revit API defined it. But I would notice that sometimes ChatGPT instead wrote create wall instead of wall create, right? Or with an underscore. Or then sometimes it would write action instead of method, and then not group the parameters like it needed to. So it was kind of really hard to tame ChatGPT, and most of that is done in the system prompt. So in how exactly you describe the way you want it to interact with you here. And I've been tweaking it back and forth to get it to the point to get really good at one thing, but that's not really, you would want it to be good at anything you throw at it, right? And so this is where I was struggling and realizing that it's still really hard to get it to be consistent and to be helpful in a broad field of tasks. And when you think about what these large language models are trained to do, it's really to just generate text that sounds good. And which it does, right? I mean, if you look at this first glance, it looks correct, right? They're just not very precise and consistent. They will, whatever you throw at them, even if they don't know what to do, they will just generate something that sounds about right. Like if you ask it to write a recipe for like an upside down bubblegum cake, I don't know. Like it will generate something for you, even if it has no clue what that is, and even if that doesn't exist, right? And so that's just something, that I think is a limitation right now for using generative AI, for using these large language models in the context that we work at, where it needs to be really precise. And then another part is that it's not the best at dealing with geometry and logic. Like, for example, if we ask it to draw the same wall now, but going like north to south. Oh, that's good. It actually worked this time. So last time I tried this, it tried to put the 5 meters as the z coordinate, and then it wasn't able to create the wall because it was basically didn't understand that to go in the other directions you had to change the y coordinate, not the z. Well, but I mean, this is what I talk about with consistency, right? Like sometimes it works, sometimes it won't work. I also had times where I asked it to create like a wall that was 5 meters long and 2 meters high, and it made it 2 meters long and 5 meters high. Like it's just not really reliable yet. So, and I think that comes from a difficulty of dealing with geometry and dealing with numbers. So yeah, we shall see where this goes and how useful LLMs and generative AI can be in the future. So this concludes the video for today. I hope you enjoyed it. I hope it was helpful and it didn't shatter your dreams too much of what is possible and what isn't with large language models and ChatGPT at the moment. It's still a path that will go down, or maybe not. We'll see where we'll get with them. There's also these articles saying that large language models, the way they get trained at the moment, will never really reach real intelligence and real reasoning capabilities. So we'll continue to see where this goes. But yeah, I would love to see you build upon this, and like if you have ideas of how to continue with them, share them with the community. I'm sure others will appreciate it. And yeah, it was fun making a video again, even though I'm exhausted now. I haven't done one of these in a long time. So I hope you liked it, and yeah, stay in touch. Bye, have a nice day.